Okay, hi everyone, I'm Fran. I'm from a company called KOREC, and I'm here today not to talk to you about BIM directly, but really about a tool that's been used more and more for BIM, drones, and drones for infrastructure projects specifically. Just to fit it into the time frame, I'm going to concentrate on, at the latter half, on a project in the A6, a road project with one of our customers, and just show you how drones can be used. So a little bit about KOREC. Chances are, if you need to measure something, we have what you need. Basically, we sell everything you could need, from GPS, total stations, laser scanners, mobile mapping solutions. There's our MX9 solution, where you just drive on the road. It has GPS, it has a laser scanner, so it's measuring everything as it drives. We have rail solutions. But really, I'm here today to talk about our drone solution. So in terms of KOREC, we have an office in Dublin, in Craigavon, and we have offices as well in Britain, in Liverpool and Huntington. And we provide for the whole life cycle of the product. So we sell you the product, we provide training on it, we support you on it, we hire, and we also repair in our workshop. So the entire life cycle of your survey product, including your drone. Mainly we're Trimble dealers, so our laser scanners, our total stations, our GPS, our Trimble products. But to enter the drone market in 2012, we partnered up with a Swiss company called SenseFly, who are part of the Parrot group. So SenseFly, as I say, produced their first drone in 2012, and we got the exclusive rights to sell it here in Ireland and Britain. So, who am I? Yeah, why am I up here? Mainly the reason is that when we started selling drones in 2012, I had to learn how to use them so I could show whoever bought them how to use them and train them how to use them. And basically I went to Switzerland and I was taught by SenseFly how to use the drones and how to train them. And I'm also certified by the Aviation Authority to fly drones. You have to get certified by the relevant jurisdiction to be able to fly. And really the bottom line, you might say, what the hell am I up here talking to you about drones if I'm not a drone guy? But what I mean by that is that I don't come from like a drone background. At the weekend I don't take out drones and play with drones. It's that we started selling these and I had to learn how to use them. And it's a point I'm going to make in a while about the type of drones that we sell. So, I mean, you'd have to be living on the sun not to have some experience of drones lately. They're just about everywhere. I think we all know probably the most common are the DJIs, which I have up there. We know now that they're talking about getting your pizza delivered with a drone. They're used for like nature programs. I think these guys in the hot air balloon here are about to crash into a tree. For sports, and a couple of months ago I came across this DRL, which is a drone racing league in the United States. It's the fastest growing sport in the United States. So what they do is they all wear goggles and they can only see what the drone can see. And all the drones are the same spec, so it's not like Formula 1 where the best car wins. It's all about the reaction. So if you ever see it, it's worth looking into. And you can see just the scale of drones as well. They seem to have come out of nowhere. When I was doing my aviation test in 2012, they barely knew the type of drone that I was using. Like, I think it was like one of the first 5 guys or whatever to get licensed. Whereas now it's just exploded in that short period of time. That's the Global Hawk, the US military drone, 40-meter wingspan. Mad to think there's something like that up there with no pilot, you know? And then of course you've nano drones that are like the size of your thumbnail. How we became involved was basically through Northern Irish Forestry, a customer of ours. And they had this disease that was affecting their ash plantations. The disease was called ash dieback, and ash dieback means the tree dies from the top down, and it was seriously infecting all the ash plantations they had. So they were sending kind of 2 solutions. One was to send a guy up into or teams of men, or people, up into the forest with handheld GPS. Now when you're in the undergrowth, you can barely see the sky, never mind get satellite signals, so very hard to locate and map where you have infected trees. The other thing was to get it flown. But they were using like light aircraft, commercial aircraft, so it was costing them an awful lot of money. And they actually came across this SenseFly Swiss company, and they approached us and they said, have you seen this? And we went to SenseFly, and that's how we got involved. So, there's a picture of me, my colleague Michelle, trying to convince Pascal O'Donoghue that he needs to buy a commercial drone. Really, you know, I know we're under cut for time here, so I'm kind of going to go through it. On that slide, what I really want to talk about is ease of use. Again, you don't have to be a drone guy to use our stuff, and that it's designed for the job. We all had the beast from the east here recently, yeah? and most of us couldn't get to work, you know, in certain parts of the country. But if you had a 4x4 with your winter tires, you could do it. So you're talking about something that's designed to work for these situations. Again, just compared against traditional methods of surveying, you're out there with your GPS or total station, no matter how hard you work that day, even a good day, you might measure 600 points. You know, what did you record? If I measured here and I measured a point here, I have no data in between, so I have to interpolate what's going on in between those 2 points, yeah? With a drone, it's measuring everything, okay? You have everything and everything in between, okay? And you're not, sometimes it's not even what you surveyed, it's what you didn't survey, and you get back and you realize you haven't got what you needed. With a drone, that isn't really an issue because you're covering everything and you have all that data. Also, if you do survey and you detect something, then you can localize your surveys to certain areas. Again, like the ash dieback disease, maybe you do your drone survey, you locate where the trees are getting sick, then you can send your teams in there on the ground. You can fly the same areas over and over, so you get your progress, you get your map, you can fly weekly, monthly, so you have your report, your documentation, everything you need is captured by the drone. There's so many things it can be used for, and again, I'll go through a lot of them as I go through the slides. There's just some of them down the end. I think at the very end as well, I'll show you some of our customers, everyone from archaeologists to again, what you're doing, construction, huge boom in the use of them. And I'll just talk about some of the ones that we're involved in. Another thing as well is safety. Say you want to survey a quarry. You know, quarry guy doesn't want you on his site. Dangerous places, okay? Something could happen. So you might have to wait to do a site induction, you might have to wait till it's closed down, there's no machinery on it. You know, with this, you don't even need to go onto site. You launch from off-site, you fly your site, you have everything you need. Really, probably the bottom line is a big thing, and this is really what will change it, is, you know, less manpower, okay, less equipment, less money. So you're getting more for less, okay, and that is the bottom line for most companies. For me, having flown drones since 2012, I'm still amazed when I see them in the air doing their thing, but what really still blows me away is the data. I mean, it's just unbelievable what you can get out of these drones. When we first started selling them, we were selling them for like the photographs, the videos, the photographic map, we'll say the orthomosaic. Now we're selling them for the ground models, and more so for the ground models. But you know, we've different sensors that can go in the drones, so they can be used for agriculture. There's thermal cameras. There's loads of outputs that once the drone lands, you basically put it into software and all the outputs are there for you. And they're very easily shared as well. I've found a few examples of that later on as well. Having said all that, drones for construction, like someone asked me the other day, now I have my drone, can I throw away my GPS? Half in jest, but no, you can't, okay? It's another tool in the box. When I first started with KOREC, we had a hard time, believe it or not, selling GPS. Sure, I have my total station, why do I need a GPS? Now you can't imagine doing anything without them, you know? And that's the way the drone is. It's another tool in the box to complement what you're doing. So I'm going to talk about, again, you know, with the time we have here today, we have two systems of drone that we sell, a fixed wing and a rotary. I guess the rotary is more popular or whatever. Most people, when they think of drones, probably think of rotary drones. Maybe you don't know as much about the fixed wing, so I'm going to talk about our fixed wing solution and talk a little bit about how it's used by one of our customers. Okay, so the drone I'm going to talk about today is the eBee Plus, and it's actually the 4th generation of fixed wing drone from SenseFly. I began with the swinglet cam, then it moved to eBee, then it moved to eBee RTK, and what we have now is the eBee Plus. So, the eBee Plus, just kind of a quick overview of what it is. It's a light drone. Okay, it can be carried by one person. It all fits in one box. You can fly for up to an hour, covering 220 hectares. You're getting 1 to 3 centimeter accuracy from the drone, straight away, without correction, without ground control. That's just a live correction. So again, you can just see the 20 megapixel camera, the potential uses for it. Multi-sensors. Okay, so the same drone, I can take out my RGB camera, I can put in a thermal camera, I can put in a multi-spec camera, loads of different sensors, capturing different data for different uses. So if I move on here, I'm just going to play this video if I can. Okay, we don't have sound today, so I'm just going to talk over it because it'll help me maybe remember some of it. So the eBee Plus, The big jump in this, the eBee Plus, is the battery. Okay, before you used to have an eBee that would fly for maybe 40 minutes. This flies for 59 minutes. Okay, 220 hectares of coverage. The 1 to 3 centimeter accuracy as well. With the old drones before, they were autonomous. So if you did a flight and then you did a flight straight after that, when you position the flight data, it may not sit on each other perfectly. This time, everything you fly, real time, is corrected to 1 to 3 centimeters. So it's just revolutionized it, because before you could spend half a day putting in ground control for your drone, and you might do the flight in 10 minutes, and then half an hour or half a day collecting the rest of your flight control. Now it's all just instant. Photographs come off and they have that level of accuracy. It's also upscalable as well, so that you can buy the drone. Before, if you wanted the drone with that kind of inbuilt accuracy, you'd buy a different drone and sell back your own. This one comes with it all inbuilt, and you can just apply the upgrade when you require it. So again, they've also come up with a camera. It's the first camera ever invented just for drone technology, the SODA camera, so sensor oriented for drone applications. So the quality of the imagery that you're getting from it is just, it just has moved on another level entirely. So again, all this has happened since about 2012. So that's the eBee Plus. Again, I'm just going to move on a little. So what I want to do is, often when I'm doing this sort of thing, I'll plug in my own laptop and I'll give you a live demonstration of how the software works. And what I want to do is I just made a video of how you would plan a mission if you were to fly some of the college. So I'll go through that and I'll just talk over the video if that's okay. I suppose what I want to get across in this video is the ease of use. Yeah, this is like, I've seen some drones. Again, I'm not a drone guy, but I've had experience of drones, because obviously we might have to know what our competitors are selling, etc., etc. And some of the controls to fly drones are just, there's bells, whistles, knobs. You really have to have a certain level of skill. With this, they've simplified it to anyone can use it. In a day and a half, I can train anybody how to use this drone. It might take you another 2 to 3 days to get your aviation authority licensing, but you can be up and using it in the space of a week. So, just start the video here. Okay, so I'm launching the Motion software. And the first thing I can do is I can pick my type of drone, and I can pick my camera sensor. So I just let it know. It's the same software used for the Rotary system drone or any of our drones or any of the cameras. So it defaults to where I was the last time, so Queen's University. So what I can do is I can just go in here, type in the location I'm flying, and just search the web, and it'll go to that address. Or if I wanted to, I could put in a lat long of the location I want to fly. Once I do that, the mapping moves to that location. You can see the college there. But I also have various mapping sources I can pick. So I can toggle between kind of street maps and digital imagery, BIM maps, different sources. So again, let's just say I wanted to fly, say, the sporting pitches here. I have 2 ways. I can import the file from Google Earth. So maybe someone else did the flight plan and I can just import it. Or I can just simply draw a polygon around the area I want. I can create extra nodes to shape that polygon and just basically drag the polygon over the area that I want to fly. So very, very simple to create the area you want to fly and define it. What you can also do is when you have it defined, you can save it. So I can go out and fly this, maybe I'm redeveloping the sports pitches. I can go out and fly this weekly, monthly, the exact same area. I don't have to recreate that again, I just load it up. So you can see down there the flight parameters. It tells you based on that flight height what the flight time is. You can see the flight time changes if I decide to fly lower. Flying lower will give you a better quality of image. Like any camera, the closer you are, generally the better quality of the image. So I've just set it there to fly with the standard parameters. You can check your data in 3D. So if you're going flying around Sligo and you're afraid you're going to crash into Penn, you can check, make sure that your flight plan is the flight plan, the software, it actually comes with an elevation model, which I'm going to turn on here, which is really, really useful if you are flying in areas where maybe there's big differences in elevation. And what the drone will try to do, I'll give you an example here. I drag it to an area where maybe we have some sea level and we have some mountains just off the sea level. What the drone will do is it will actually try and maintain a certain height above the ground level so that you can get consistency in your data. Other drones, they won't, and you know, you might be 100 meters above one point, but you might be 200 meters above another point. This way you can see when I'm flying kind of from sea level to a hilly area, you can see that it's actually stepped the flight plan to keep consistency in the the flight data above the ground level. So I'm just going to turn off, I think, the ground map and bring it back and just show you. Now, one of the other gifts about the software is that it can simulate being connected to a drone. With some drones, the only time you learn is actually when you're flying, and it's nerve-wracking enough, that you're flying a drone, and to get used to everything, you need to know why you're flying it. In this case, I can actually simulate being connected to the drone, and I can practice flying and get used to where everything is on the drone before I actually take the drone out at all and go to site. So again, all this can be designed in the office, and just, it's a small file with all the route in it, and I can just send this email it to someone if I want on site, and they can load it up on site. So for me, I'm just going to put in my landing position. Let's just say I want to land on the sports pitch there. And one of the nice things about the software is, if you scroll in here in a minute, once I put in my landing, is, let's just say usually you try and land into the wind with these. So I was going to say the wind is coming from the south, so I'm going to land into the wind coming from the north. What you can see as well here is I can move the landing position. So if there's something my way, I can move it. And you can see it even tells me the height the drone is going to be at those locations in my landing. So if I knew there was something there and it was 10 meters, as long as I knew I could clear it, that was fine. I can also narrow the approach path too. So if I'm trying to come in between two high objects, I can narrow the flight path. So that's basically everything. You've told it where you want to land, where you're going to launch. You set all the parameters for the flight. Next thing you might do is load the flight mission. Again, you can see how easy the software is, and then you load the flight plan and launch. Again, it's hand launch, so out of the box, 2 wings in, 3 shakes to start the motor, and a hand launch. Really, really easy. Some drones have large catapults and stuff like that that make launching and getting your drone much more difficult and time consuming. With this, it's out of the box, wings in, load the plan and launch. It can be flown from a tablet, a laptop, anything at all. No, don't really need to have any special drone flight skills. It's more about just common sense and good planning. So I can now simulate the flight. So again, you would have heard some of this if I had sound, but again, I can just talk about it. So it's launching here. When it launches, it'll go to the furthest away point in the mission and start taking the photographs automatically. I have a number of controls as well. Up the very top of the screen, you'll see where I have things like hold position, land now, resume mission. So I actually can control the drone if I want. I can get it to stop, I can get it to go certain places. I think in this case, just you can see it taking the photos, see the little squares there, and you can see the number of photos iterating over here, where I have how much space I have left in my SD card. So I have control over the drone, and everything can be controlled and flown from a tablet. Okay, so that's really it. I take the photographs are stored to an SD card. I take the SD card out. The images are already georeferenced, as I said, to somewhere between 1 and 3 centimeters. I just load that then into my software, and that is that. So if I just move on here. So that's motion 3. All the data then goes into Pix4D, that's the processing software. And it's just a case of loading in the photographs, and because they're already geotagged, I can just pick my coordinate system, and then I can just select my outputs. Very, very easy stuff. There's nothing fancy to be done. You just have to follow 5 or 6 steps, and then you get all your lovely data. Okay, so just to highlight some of this, rather than, I have so many data sets I've been so long now, I said I'd just pick a certain project. So this was the A6 in Northern Ireland. It was a partnership joint venture between Graham's and Farn's. Graham's and Farn's would both be long-standing customers of KOREC, and we would have worked with them for years and years. So there is a comment from one of the guys, Nick Kelly, the chief land surveyor in Graham Construction, when he got his eBee. So you can see the lads, they're having it handy there. They pull up the old Jeep, they take the seat, they throw the eBee in the air, and it saves them having to march around with their GPS all day. Yeah. So I have to commend the guys in Graham's. They've probably put the eBee to more use than any of our other customers, and they're right the way they do it. They use it, they're not afraid of it, and just show you really what a difference it's made to them. they gave me this, they said this is probably the best example of it. The A6 borrow pit, I actually had to ring him and check the figures, you know. So when they're building the A6, they took 181 kilometers cubed from one of the borrow pits, yeah? So that's a lot of material. And that, you'll see it in a minute, I actually have a video of it. That is such a big quarry area, borrow pit, that it's actually not safe to send surveyors in there with traditional GPS or whatever, and total stations or laser scanners to survey. If they did go in there and try and do it, his estimation that a full topo survey would take a few surveyors, maybe 3 days. Okay, they fly it every Friday in what, 17 minutes with the eBee. They don't even have to go in there. Okay, so total management of their site, including their quantities. So if I go on here again, I'm going to play another video if that's okay, and just talk a little bit over it. What I've done is I've brought some of their sample data into our software Trimble Business Center just to show you. So this, I think, is that borrow pit K, and you can see from the 3D model there in their, what was it, 17-minute flight, the level of data that you can get from it. Again, just think of traditional methods of trying to capture stuff like this, all their stockpiles, spoil heaps, everything, all the materials. As part of this video in a minute, what I'll do is I'll actually show you how easy it is to extract the information from this. Say you want to do a quantities calculation, volume calculation. It's all just very, very easy. You have everything you need already. It's just a case of extracting it. So one of the outputs you get, what we're looking at there, is the point cloud. So that's the digital terrain model. But what you also get, these are automatically generated outputs from the software. I didn't do anything fancy. Is a contour model. I have the contour model underneath. Hopefully, I think I turn off the point cloud here in a minute that you can see it. So you get kind of traditional outputs as well. You know, you don't just get point clouds. You get CAD drawings, you get shape files, you get PDFs, and I'll give you examples of all of it. So again, all automatically generated. Nothing clever here. I just loaded in the photographs and I pressed the button. So let's have a look. Let's see, what do we do next here? I think there's another data set coming up. Okay, so I'm just opening another. So this is actually another section, and here it's just, I think I just showed you the photograph and kind of the quality of the imagery you can get. So like this is from 120 meters, you know. So like this is not just used during, I mean, even an as-built, when the survey is done, you know, when the road is built, they have to send out their surveyors, measure central line, embankments, all, you know, everything. Now they're just flying with the drone and they have the complete record of the entire site. And they've had this complete record through the entire project lifespan. This year, what they gave me here, this is actually the Genio, the finished design for the A6. The Genio file, so I brought that into Trimble Business Center and I made a surface out of the finished road design. And what you'll see, just to prove kind of the accuracy of the drone, is you'll see here in a minute where I've actually got the point cloud flown by the drone, and that's the actual road design. So you can see, you know, how good is that for guys in construction to be able to see exactly now where he flew today, where the finished design is meeting with the existing ground. He can tell his cut, his fill, he can work out all these quantities, everything, all there, you know, a few minutes to fly it. So I think here as well what I do is I just show you, you know, how you can do a simple volume. I think in this case maybe just extract a stockpile. So if you've got a stockpile of material or a spoil heap or something, you want to know what's in it, you can go into your point cloud and you can just segment it, just basically cut it out. And then you can put that on a different layer of information, and then you can find out what material is in it. So, yeah, what I'm doing here is I'm just segmenting that stockpile of material. And what I do is I put it onto its own layer, if you like. So whatever was in it, 804 or sand, gravel, whatever material it happens to be. Then I can turn off the rest of it and I'll be left with just the surface model. doing here is, hopefully you can see it. I know the display isn't very good, but what I've done now is I've triangulated that point cloud and made a surface out of it.
Are you trying to get the volume?
Yeah, exactly. And what I'll do now is I'll work out exactly the quantity of the volume inside that. You'll see there now. I'll just see it. Once I turn that off, you'll be able to see exactly what I've got there. And I'll turn off the point cloud. So now I'm left with my triangulated model, DTM, and then I can just go in and work out how much quantity is in that. So that can be, that's just a very simple calculation. I could have compared the design and worked out my existing ground level to design. I could work out my existing ground level to the original ground level, and everywhere in between from the drone data. Okay, so just to show you as well what the guys, some of the other outputs here. One of the things we had a problem with at the start with the drone was sharing information with people. But really, the software now has produced outputs you can share with anyone. Like this is an output that goes into Google Earth. I can show you exactly the flight. I can click on any one of those pin drops and they open the photograph that goes with it. So you can give someone the data in Google Earth. You can give them the data in Google Maps. There's even a 3D PDF format that you can give them the data in. So again, you don't have to have fancy software. You don't have to have a big computer. You can produce the goods in easily digestible format that can be shared with just about anyone. There it is in Google Maps. Yeah. So this was a thing at the start that people weren't able to use the data being generated, but now there's so many different ways to share the data with people that they can use. So I'll move on from there. The guys on the A6, as I said, they were really great. They really took to it, so they've created their own YouTube channel and they broadcast all their flights. So you go on there and you can see the flight they do every week to week. Actually, I'll just show you the main line if you don't mind, because I just think it's great. So from the drone data, you can make your videos. So this is the A6, and like this for me anyway, this is just fantastic. So what you'll actually see is he's going to fly the where the road is going to be, but it's not built yet. And what you can actually see up here is you can see where they've got the 2 fence lines, yeah, for where it is, and that's where the land is. You know, that's where the new road is going to go. So you can see all the existing ground, you can see the work as it's happening up here, you know, and you can fly all that anytime you want, produce the goods, share it with whoever you want to share it with. So drones in that space, you know, short space of time since I was involved, say 6 years to now, you can really see what is achievable with these drones, and you know, it's just going to, it really is becoming an essential piece of kit for the industry.
Permission to fly that path?
It depends on where you're flying. You're right. Certain permissions are required if you're flying, say, near airports, aerodromes, military bases. For this area is considered general airspace, so anyone can fly it. Yeah. If urban areas, stuff like that, you can fly them, but they may, if there's no airport, for example, but you may require a risk assessment plan if you think there is any kind of danger to the public. But these can be minimised. So say I did want to fly, say, Galway, which doesn't have an airport at the moment, we'll say. To minimise risk, maybe I could fly in the summer, early in the morning, when, you know, or, you know, late, you know, when there's less people around. So you can fly these without permission if you require. So you can see the way the guys are loving what they do and loving sharing it, and that YouTube channel is there for all to see. So again, that's just an example, you know, to give you an idea of maybe the types of people using: archaeologists, councils, construction, wind farm, planning, as well as surveyors, agriculture. But for, you know, as a tool to feed into the BIM, the amount of information that can be generated from a drone flight and that can feed into BIM systems is just, you know, there's no doubt of its use. So I think we're doing.
It's big business.
It's big. It is. I'm actually surprised that isn't bigger. I think it's just people take a while to really adopt and to come to new technology.
Use it to maybe inspect
their power lines. Yeah.
Power lines.
Yeah.
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 Thank you so much.
So, yeah, thanks everyone. Appreciate that.